Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for Similarity, musical tunes. And what we've been working on lately is a SoundPlayer, so you can select a tune and hear the notes of it played back to you. All right, it's a really ugly library, so I feel like we've been struggling a bit. All right, but what we're going to do is we left off. We were in the playground, and whoops. We were in the playground, and we had just added this. There's the notion of a user event, and so in the track, you can put a user event, and it causes a callback to you at that point. And we added this, and I was puzzled because it seems to be producing one of these events for every time, one for every note. Okay, and about 2 minutes after we left, I realized, you left it in the loop. Okay. I know, it's like, how do you get anything done? All right, so let's run this. I think I can do that down here. Should have one event after the sound. Yeah, okay. All right, now this is... I won't say it's the height of ugliness, but my goodness, this is pretty darn ugly. So here's the definition of the callback, the type of it. Now, I think what we can do, we got this set callback. I think it really just wants this type, and hopefully we have that. Okay, I'll just paste that there a moment. I'm just going to duplicate and comment out. All right, so this optional, all of this should be that. And that should work the same if it passes type checking. Okay. Whoops. Wrong run. Okay, let's just stop. Whoops. Oh, good. Okay. I got us there before, but all right. I mean, the reality is they just tell you it's an opaque. No, they tell you it's this complicated type, but turns out we're okay. All right. So the process of this, I don't know, I keep complaining. It's just horrid though. Okay. So what we've done is we've got a loop here that runs through, these are all the MIDI notes for the C major scale. Okay. And it's half steps. So if you got a music background, C is 2 half steps up to D to E, 1 to F, 2 to G, A, B, and then 1 to C. Okay. And we have already created a track, and on that track, we're going to put a note. So that's the notes of the scale. We put those in, and we're just looping across. Then at the very end, now I did this at 10.0. I think I can just do it at time because we incremented time. All right. So let's do that again. All right. So I'm trying to get one after all the notes. Okay. And now the time is really 9. Okay, because I guess there's 8 notes here. 8 notes in an octave. All right. So we added all the notes. Then we added one last thing after those notes at this time that's event data. Now event data, I just put some junk in here. I don't really care. Now, interesting. Okay. So I got event data on there. Now, how did I get the callback in place? So I suppose I could put my own data there. So if I had something interesting to say, I could do it. I think it can be an array of bytes. I'm not quite sure how you get that stuff, but okay. But anyway, we put the event there, but the event is not doing anything. It's the callback that does the work. Now the callback, we just printed these times. The event time is the scheduled time, and then I think this start slice end slice, I suspect it's kind of like the jitter, the variation in these, that it promises to schedule it between 8.9629 and 9.009. I suspect. I don't really know. I'm not going to find out from the documentation. That's pretty clear. All right. But the other things we could pass back, I don't know what they... Unsafe mutable. We'll have to find that set. No. Somewhere I saw documentation of this. Whoops. We get a pointer, a music sequence, a music timestamp, music event data. So there's my user data, and the two jitter times. So I can get back that user data if I need it. The way we're using it now, I don't really need it. I just needed something to put in there. All right, and then this pointer, I don't remember it. Let's see. I think we might have better documentation on this in here. Not really. C set muse. I mean, there's that slice beat and slice. I don't know. Okay. Yeah, I don't know what that first argument is. Isn't that terrible? All right. So, way we set this up now, we have a function. Where to go? There, right there, where I was looking. Okay. This is our callback function. It's a lambda. So it takes 3, 4, 5, 6, 7 arguments, most of which we ignore. And does what we ask with it. Okay, in this case, we just print the time. The way you set it up, you created the player and you tell it, hey, in this sequence, I want to be called back. And I don't remember what this parameter is either. Let's see, back to our definition, set music sequence callback in client data provided back to the callback. Oh, okay. So this is different client data. We can pass more, basically anything, pointer to anything, to the in client data. Now, somewhere I have a Stack Overflow or something that demonstrates passing a method, using this to actually pass a new method back, and then the callback can call the method. I don't know if we need to be that complicated. Okay, so, I mean, what I want to do, well, the reason we need this, the player starts things off on a separate thread and then runs until it's done, but it returns to you immediately. So, while it's running, I mean, it kicks off the sequence and then returns to you. So you hit the play button and now it's playing. All right, now nothing stops you from hitting the play button again. I mean, we haven't done anything that would. All right, so one thing I'm trying to get out of this is I'd like to be able to stop the play. Now we have a stop. All right, so let's see. I can do this. Got kicked off 8 or 9 of these things. Now I don't know when I stop, I don't know what I'm stopping. Yeah. I think we may need to make the actual player a singleton. Okay, I picked a long song apparently. All right, well, there we go. Okay, so what the reason, well, one problem we have is we'd like to be able to stop the player. The other problem is we would like to be able to turn off this button until the player has finished. Okay, the problem is we don't know when it's finished because it just runs. And as it turns out, it's even worse than it sounds. When it starts running, it just keeps running until you stop it. Even though it's run out of notes to play, it's still taking up the resources and all that stuff, and it's sitting in the background ticking away. You know, no, I'm at beat 1,700,052. Still no notes. You know, it's just going and going and going. So the only way to actually stop it, well, sort of stopping the program, we need to somehow know when the music has ended. So that's the reason we did this spike. We wanted to say, can we get a callback when the music has ended? Okay, so if this is our only user event, we're able to just, you know, that we just stop when that happens. Okay, and so what we want to do is stop the player, and ideally we'd like to gray out this button while it's not available, and then turn it on when it is. Okay, and then the other thing that's going on when we hit play multiple times, I'm pretty sure we're creating multiple players, and that's kind of a problem. All right, let's get down to sound. Sound stage. Yeah, here's our play. We, well, sound player, where's that set? Player. Okay. So let's see, play, call SoundPlayer play, this method, which creates a sound player. Okay. And then eventually the stop says stop that player, but which I think works fine for if we've got one player. Okay, I stopped it. It's more problematic if I kick off two, right? Then which one am I stopping? Well, I'm stopping the most recent one. We've lost control over SoundPlayer. Once you create it, and if you create it, call it again, it creates a new one. It doesn't do anything with that last one. So I think we'll need to worry about that somehow. And the worst of this to me is this library we're using, the audio toolbox, it's called with C conventions, and it looks like C code, so I'm pretty sure I'm safe in saying it's C. But it just doesn't, you know, you have to explicitly dispose things and stuff like that, and we didn't do that. Now we have another layer going on here. So SoundPlayer, the way we use it, we don't know anything about the MIDI stuff. Okay, just there's a MIDI note number, but this file uses Audio Toolbox. SoundStage does not know anything about it. So this one is kind of a little bit of a wrapper to it, and it knows, like here we can see the notes going in. Okay. Now, notes is empty. Okay. So we put those in. Right. So unfortunately, like, testing this is just really a bear. Like this one, I don't know how to test it, frankly, without, well, I could I could duplicate a wrapper for music player stuff, but it's, I wouldn't know the real behavior of it, because that's kind of what counts. And I could implement something that's sort of my approximation of it, but even then we still wouldn't be using the real thing. So it'd be another layer. Now this layer we do test to some level. The one thing I know we test is this conversion to NoteInfo. So what we do is symbols are in our note domain, our program's domain, and then NoteInfo is sort of an intermediate form that knows about MIDI, and it knows what types the MIDI stuff wants, and so it converts our notes into a series of these. And so it produces turns an array of notes into an array of NoteInfo, notes and rests into an array of NoteInfo. Okay, and then accumulates the result there. Okay, so well, okay, so but I don't think the rest of this we've effectively tested. I mean, we've tested it manually, but not programmatically. And I'm trying to keep it simple. I mean, it's like doing the minimum stuff it's got to do. We create a music player, we create a sequence, we set the player to hold the sequence, we create a track in the sequence, we shove notes into the track. Yeah, there's the track, and that's it. Okay. And so at that point, we've got a properly configured player. We can call play on it, and it takes care of all these things. I mean, the sets the rate and starts the player. Okay. Oh. Now, how's this going to work right? So, the problems I have. One is, let's go to here, record these. Okay, so we've spiked the callback. I would say we've done that. I mean, we started it last time and finished it in 12 seconds today. Okay, but we've demonstrated that you can create a user event after the last note, and when that is triggered, it calls a function we specified, or a closure we specified. So that all sounds good. Okay, now preventing simultaneous play. So, okay, yeah, that's one thing. We wanted to stop. We don't want to let you hit the go button until we're done. All right, now, how are we going to know that? That's going to be tricky. And I think the answer is that probably sound player needs to be a singleton, and we can just ask it and have it tell us. Okay. Now, I don't know. All right, the next one is stop and dispose player when done. Okay, that's something we ran across in the documentation, that the player does not stop or dispose by itself. Dispose I didn't expect, but stop I was a little surprised about. Okay, now it could be because it's done, or it could be because we've switched selections. We want to stop the current player. Okay, now there's another piece. Yeah, so the other thing is I'd like to notify, and this may be redundant or it may be not good, but I want to update the player state when it's stopped. Well, when it stops. Yeah, I don't think we care if it naturally hit the end or if it was stopped. Okay. Now, I hate thinking through sync code because it's just so error prone. When I was in grad school, I was the TA for the operating systems class. And it's like you watch all these people, they're in grad school for operating systems, and practically every one of us, not just them, but all of us, make mistakes in dealing with sync code. Now, async await and cues and a million other solutions that we've had, they are all challenging, and we're still not quite over it. All right. So what we demonstrated though is we can get a callback when the player finishes what it's doing, and that means we've got some chance. Okay. And I think, let's see, where's sound state held? I think it's held in the wrong place is what I think. So right now, yeah, sound state is owned by this thing because it wants to know. Oh, it needs to know things. The problem with these is, well, no, they're not. I was going to say they're transient, but they're not really. The sound stage is created once. I mean, we have one button for it. It's exclusive. Pretty sure if you turn it off, yeah, we got a new one. Okay, so let's do it this way. Let's switch, and we'll change the playback speed to slow. Switch to statistics. Switch back, and we're back where we started. Okay, so that's that's a problem. Well, it says the view. Well, what does it say? We're throwing away that analyzer when we leave it. So it's not like we have them all sitting around and we're activating one. It's thrown away. Now, that may be a problem. It may not. It doesn't. Well, the fact that the view is thrown away is not so significant, but the fact is the sound stage is thrown away. And like somehow we have to dispose of that player or make sure it's not reused. So maybe let's see if it's like getting my path through this thing. But I think much as I hate singletons, like on my list of blogs I could write is like how bad singletons are, this may be a place that we have to do it because we've got this resource being the MIDI stuff. We have to control its lifetime, and we do not want you creating a bunch of sound players, because then we lose track of which one's which and how do we get control of it, I think. So call this experimental, but I think what we got to do is make this a singleton, and then instead of it may not have to be, but if it is, instead of some of this stuff is happening at constructor time, we're going to have to change the lifetime of this as well. Gosh, and is that going to solve things? Well, what that does solve is it says even if you throw away sound stages, you are not throwing away the sound player. Okay, so the sound player is wherever it was, and we can get it. Okay. So I think that will help something. Okay, one thing it should help is we should be able to move the state over to the sound player. So this is owned by the player. Now, how you get notified or how you find out the state, I don't know. We're going to have to work on that. It's managed in here, sort of. I assume if you're playing, it's going to play, kind of thing. I'm gonna take whatever state you tell me it is, and that's what it is. I don't know if that's quite well. Okay, I think that will help us. It's kind of a design question for us, but I think if there's only one player, whenever you play, you're getting whatever it last played, and that seems like a good thing. Because then it can say, oh, turn off the existing music player and stop it, dispose of it if you need to, or dispose of the sequence that's in it, or whatever you got to do. Okay. Yeah. But the more logic is in here, the worse it is, right? I mean, all right. But the thing I don't see a way through to is this sound player is going to have a status. The actual MIDI player has a status. The sound player can get it, and it can even sort of track it. Okay, like once you hit play, we're going to say this, the new status is playing. But how do you find out when it stops playing? It can change its status, but how will the soundstage find out? Right? That's the trickiness. And I think we're going to have to, I don't know. We'll see. We may set up the combined stuff to do notifications, kind of like Publish does. And then maybe we're publishing that state. Look, you got a notice here that says, hey, check your state. Okay. Gosh. All right, let's make this a singleton. Ugh. Okay, so I'm going to say there is an instance. Static. Well, wait a minute. Is there a way to do this in Swift? I thought they might have a once or something like that. No. Okay. Yeah. They're just doing private init and create the object. Okay. I guess that's what we'll have to do too then. There are languages out there that have a little tag you can put on. Maybe Kotlin does or something, but that you can mark something as once and then it only initializes one time. All right. But static instance equals sound player, and I'm going to start empty for now. Okay, now. Yes, var. And notice I'm not even testing anything at this point. We will have to update our other tests, but okay. So right now, sound player does not know anything when it initializes. So we're initializing it. We can't do that in the init. We're gonna have to initialize that on the play, I guess. Okay, so we'll need the notes and the player. Unfortunately, well, no. Maybe what we need is a function. Let's do that. Let's create a static function instance for symbols with symbol. Okay. Returns sound player. Okay, yeah, this is it. So we're going to make more kind of like a factory kind of method, sort of. I think we can say self sub symbols. Okay, and we don't. Oh. Must use a required and Okay, well, let's just return SoundPlayer. Okay, now the other thing I did over the weekend was I put in SwiftLint, which has a bunch of rules for kind of quality code. Nothing too difficult, but it was kind of a couple hours of shuffling things around. I probably should just run their automatic fixer and let it deal with spacing issues and junk like that. But I did the work anyway. So it should complain about this, because I think saying return when you don't have to is, yeah, that's a SwiftLint complaint. We have a rule called implicit return, and it says just leave out the return when you can. Okay, so now I think anybody who creates this could just as well call instance, and they'll get the same thing. All right, so let's make this private. We'll let the compiler tell us all the places that don't use it, and then we'll just make them call instance. Okay. Okay. I'll run tests. Yeah, it's basically resource locking, because I kind of want to control how this MIDI player gets used, when it gets stopped and started, and when do I dispose of things. All right, so some test care. Yeah, and we're using Swift, so it's Java-like, I guess you'd say, C#-like. It's got a little bit of functional stuff, but probably comparable to what they have, maybe a little more. All right, our test pass. Let's run this, make sure it actually runs. And unfortunately, when we're testing pieces like this that can only, we're not really testing the actual system until we run it, regrettably. Okay, this is a shorter one. Bump up the playback speed. Okay, and I mean it ran. Okay, so let's make SoundPlayer provide static factory method. Okay, you give me the notes, I'll give you back a SoundPlayer that a SoundPlayer configured for it right now. But what I want to do is make this the SoundPlayer. So I'm going to rework the configuration. Let's create the instance. No, let's move the work into this. Okay, so result is SoundPlayer, and we're going to return result. Okay, and then I want to say NoteInfo equals this stuff and configure player. I don't know if he's going to like that syntax. Okay, so I'm kind of inlining the stuff that happens in SoundPlayer constructor. Okay, he's okay with self as well. All right, that's another one that I didn't do by default, but you can reference the class as self, and sort of from a style perspective, it's kind of a recommended style. At least from SwiftLint. I don't know if I totally like it, but I mean, if I do a rename, it won't have to rename these. But on the other hand, rename just worked, so it wasn't a big deal either. All right, so now I don't think I need these two lines because I'm doing them in the instance, and everybody's going through the instance because this is private. Okay, Let's do this. Okay, so I'm just starting it empty, and I'm going to configure it before I release it to the world. Okay, so this should just pass. And I think, again, I probably... Well, I'll take my chances, I guess. This is pretty mild. I'm going to delete this. I'm going to delete all this. I'm still going to leave a private init because I don't want the default one out there with people creating it, because they're supposed to go through this thing. All right, now we don't need that. Okay, and this. Now these tests, I think this is really kind of redundant. All right. Let's find the tests. SoundPlayer tests. See, they're mostly checking NoteInfo. I don't think they're... Yeah. What's weird... I think maybe these tests should just check to NoteInfo. They're not really doing anything with the instance, and the instance doesn't need to store NoteInfo around, I don't think, because it can convert it right away, and then it configures the player with the NoteInfo, and that creates the track with all the notes in it. So there's no point in keeping this NoteInfo around. All right, so let's work on these tests. Okay, we create some notes. SoundPlayer. Actually, we'll use player.info. Let's just call the NoteInfo. To NoteInfo with the notes. And then this is really actual. Okay. And that's the converted notes. This is kind of a compromise to testing. I'm providing this function that my test class can run, and knowing that it's invoked in here, and it's sort of the last minute I can look at stuff that's still in my domain, this sort of transition domain, and before everything is done in the low level MIDI music player domain. Okay, so what I've done is I'm no longer... That test is no longer looking at SoundPlayer. It's looking at TUNE-23-17. And this one, I'm going to do the same thing. I'm just going to say TUNE-23-17. Capture this as actual. And then don't capture this. Yeah, because these tests were not testing anything about the player itself. Only the testing when you converted it to NoteInfo, did you do the right thing? Which is not a hard conversion, but it's a little bit. I mean, it's running through each symbol, it's deciding if it's a note or a rest, and working out this and that. We've still got this 4 in here. I think we don't have enough information in our description to know what that 4 should be for real life. It just sort of assumes quarter notes, basically. Okay. Now, these should run. I guess I don't think I ran them yet. Okay, so SoundPlayer tests looks at TUNE-23-17, not the SoundPlayer itself. Okay, and that's cool. Okay. So we're kind of shoveling things around here, but instead of result.NoteInfo, I'm just going to inline this, sort of inline it. And now nobody's touching NoteInfo, I don't think. Let's find references to it. Should be reads, but no writes. initialized. That line's gone. Configure player, that line's gone. Okay. That means this is gone, I think. Okay, so what we've done is we've compute NoteInfo on the fly, so the field is no longer needed. Okay. Now, instance. I don't know. I want to call it make usually, but it's almost more like configure. We'll hold off on the name. Okay. All right. So now the notes are plugged in when you call it, create this instance, doing this bit of code. We don't care what it does. And then we call configure player. And now when we call play, we're sitting around ready. Okay. So I think you're creating a new instance, right? So I think we can make this the static one now. Okay, I'm gonna say configure. Okay, and then I'm gonna call this instance var. Well, really it's not var. Let instance equal sound player. Okay. So we've created one. Now instead of this, I'm going to say, well, we're not going to create it. I'll do it step by step here. We're going to do instance. We're going to configure only the current one. Okay. And then configure it and return it. Okay. All right, this should be the same. Then we'll do some inlining. Okay, now I'm not sure how public I want to be with this thing. Can you create one yourself? Well, if you do, you haven't configured it. And so when you go to play it, it's all going to be messed up. Okay. So let's make this private. Okay. So right now the only way to get one of these is configure. So let's call it make. I know I'm bouncing around here. Okay. So if you make this thing, we don't need to create instance. We've already got it. Let's just do instance.configure and return instance. Everybody should be good with that. Whoops. Oh. That's probably a Swift thing. Swift lint. All right. And just because we've made a few changes, I'm going to run it again. This one only has 3 things in it, and I believe this one's the fast one. We'll play it a little fast. Okay, and then let's do no scalon. Okay, you can hear Deck the Halls in that one. Okay, so we've made SoundPlayer a singleton and configured by make. Okay, now this is where I'm going to start worrying about who does what when. Okay, so right. So the problem I have, I think the fundamental thing I'm trying to make happen is if you call make, we should delete the old player's stuff. Okay, we should stop it and delete it because you've selected a new one and hit play basically. So let's see what we have to do that. Yeah, I think this is the key thing. Okay, so we're going to get one thing we want. This status thing is just, let's just let, well, I think really we're ignoring it because it's a stop. We don't really care so much. Okay. I guess this is, let's see the rules for music player stop. Does he require, he requires a player. Okay. This theoretically could be nil, right? So, that's exactly the kind of thinking I hate to do. All right. So if music player is not nil, if there is one, we should stop it. Okay. If music player instance is not nil, stop it. Okay. I think well, we may be able to do some cleanup after a while. All right, so if the player is not nil, then stop the player before we configure the new one. All right, so I think, I mean, that shouldn't break any tests, more because of weakness in our tests than anything else, but right. And I think we've now solved at least part of that problem of playing twice. Okay, so we're here. We're going to play Re1. All right, so I'm going to play Right. So, okay. So, oh, that's a relief. Okay. So that is cool. Singleton makes it so you can't play twice at the same time. Singleton sound player. Okay, that is progress. Now, we're about to destroy everything inside it. Can we create a player earlier? All right, so I need to figure out if we can delete sequences or how that works. Okay, so here's new music player. We can dispose it, which I presume disposes anything inside it. Set the sequence. Setting a sequence overrides the currently set sequence. So I think that gets rid of it. Does it destroy it? That's hard to know. Start. Okay, and I wonder if this can be set as it's playing. All right. Music sequence. There's a dispose. Cannot be disposed while a music player has it. So, like, there's a way to attach it, but I didn't see anything that would take it away. Okay, there's new music player. Dispose. Set sequence. Sequence cannot be set while it's playing. Okay. Get sequence. Set time. Get time. Get time for beats. Okay. Toast time. Pre-roll. Start. Yeah, I don't see a way to delete a sequence without knowing what it is. Unless, I mean, I don't know if I trust set sequence. It's really kind of an underspecified deal here. Set the sequence. Cannot be set while it is playing. Okay, so we just stopped it. That's fine. Setting a sequence overrides the current sequence, but does it delete it if it's going to get rid of it? I just don't know. I really don't know. But I don't see a way to get the sequence back, so I kind of have to assume it will. So it's like, should I create a brand new player? I mean, it tempts me to just write over the sequence and keep the player handy. I really hate to guess the specification based on behavior is really kind of beyond the point of a specification, and it's just not obvious what it does. I mean, I kind of think if I dispose of it, I would expect it to dispose of anything inside it. Same thing with set sequence. I would kind of expect it to replace it. Okay. Will override. I hope that's overwrite. I mean, it's not really spelled right for either one. Will override the currently set sequence. I think it will overwrite it. I mean, I suppose I could keep the sequence around and then dispose it separately. We're going to have to try it, and then I'm going to have to learn how to look for leaks. All right. I mean, the easy way is just dispose the music player and you're done. But returns to status. The new one. Okay. All right. We gotta own it. All right. Right now, that's being created down here. I almost wonder if I should, when I create it, okay, let's move the creation. Let's try and create it once. All right, so that is here. Okay, so we've created a music player. We wrote the name in here. We don't really need this anymore. Oh, we do, because it's got to create one. I don't know if we do. Let's build and see. We're going to have to run it to see this one. All right, so if there's an error, okay. Player set sequence. Okay, so I should be able to do this. I should be able to remove this. I'm going to have one player. I keep it around. When I need to, I overwrite its sequence, and I'm sure going to hope that settles it. Okay. I don't think we need the status equals 0 here. We have whatever status it has, and at the end we're going to care. All right. The only thing is, all right. So the bad thing is, oh no, we're creating a new player each time. Okay, so if, no, we're not. All right, so this way we're creating the player once. I guess the problem I see is now we only create one player. If it has a problem, we're stuck. Whereas the other way, we try it again. All right, so I'm going to undo this. Oh, golly. Okay. So let's worry about this lifetime and then. And NID is not going to worry about it. All right. If the player is not nil, then we were running one already. We should stop it and we should dispose of it. Right? Because we're going to create a new one in just a moment. Okay. So we're not worrying about the status because we're just trying to stop it. So music player, it stopped. There was a dispose, wasn't there? Dispose music player, okay. Okay. All right, so now we're saying when you create a new when you ask to create a player, we're going to stop whatever existing player there is, dispose of that player, and reset the status. Okay. I'm going to say this is really, well, maybe the status should be down here. Okay, we're just totally getting rid of it. Okay, and this is really like configure new player. And this is well, I want an instance method. I'll just do it this way. Oops. Make method. This is, well, configure new player, dispose, delete existing player. Okay, and I'm going to make this an instance method. Music player. Take all these instance calls. Okay, pull this down. Okay. Well, this reads better anyway. Delete the existing player, configure a new player with the symbols, and return instance so you can work with it. Okay, now we get a new player each time. Okay. Set sequence, all this stuff. All right, now interesting. Sequence doesn't even leave this method because it's all in here. All right, but that's the setup you can do before you play. And then the play, we take the speed and then we just start it. Okay, now we're returning states here. All right, let's run tests. You know, I'm wondering if this NoteInfo stuff, maybe that should be in the calling class. And we just take the responsibility to pass these in. I almost think it should. Okay. At any rate, we now delete the existing player, dispose of it completely, reset it, and then build a new one with a sequence and a track. We've populated the track, and when you call play, we set the speed and start the music. Okay, when you call stop, we stop the player. All right. Feel like this is a little bit of a milestone for it. And this is the stuff I don't have a good way to test, again, without running the actual MIDI system. Okay. All right. So let's see what we did in this. Mostly it was the dispose, I think. Yeah. And rename. Okay. Dispose of old player before starting new one. Now, I guess I want to check if you hit play and then stop and then play, you are not rebuilding it because you've already, well, no, is that true? Let's see SoundStage. It does rebuild it. Okay, we might be able to work that over a little bit. All right, let's see where we are here. Prevent simultaneous play. I don't know if we've done that. All right, so what that would be, let's set it to slow and pick a long one. That's slow, all right. Okay, switch this, go back here. We have a new player. Oh no, it does. Okay, good. Good. Okay, so we have prevented that even across separate issues, separate stages. All right, stop and dispose the player when done or switching selection. That's, well, we're doing that. We're not doing that. This is really 4 combinations, right? No wonder I can't make sense of it. All right. Last one. Okay. Stop the player when done. Okay, stop the player when done. We don't do that. Stop the player when switching selection. We do that. Okay. We'll have to make sure we do that. I think we do that. Okay, so if I start this play, switch. Okay, so yes, we do. All right. Dispose the player when switching selection. I'm not clear. Dispose the player when done. I don't think we need to. Well, this is when tune finishes. Okay, we have to hit stop. But if we take care of it, the deal is we're taking care of it every time we switch. We make sure we delete the old one before we switch to it. Switch to the new one. We don't have any moment at the very end where we know things are going away, but the only time that happens is when the app closes. So I would say we'll let the operating system deal with that. Dispose player when switching selection. Yeah, we do it. Well, it's really when playing a new selection, right? Yeah, but I think we do that. Okay. Now, the thing we don't do is we don't give you a way to know the state of the running thing. And if there's an error, we don't really have a way to get it back to you. Well, we kind of do. I don't know. It's a little... All right, let's see where we are. The way we get it back to you, when you say play, we say, okay, we're playing, or else we say there's an error. And then when you say stop, we say, okay, we're ready, or there's an error. But that's only on stop and play. So I think it's our responsibility if there's an error. Okay, we update the message. And I think we should do the same here. Oops. If it's error, we're going to put an error, and otherwise we just empty out the message. The message starts empty, so I think that's okay. All right. And I don't have a way to test again. Initialized. All right. Let's just say report error if stop finds one. Okay. Now this feels funny. Is I think we can just initialize it. I'm going to pull stop next to stop. I'm not sure uninitialized is meaningful for us. Okay, so if you say play, we find your tune, and if assuming there is one, we play its symbols. I want to deal with that too. Sorry. Improve speed scale. It's not really making sense to me. All right. Anyway, we tell it to play, and we override this so we can override this method in tests, this one, and make sure, I guess we can check for an error. Okay. Now, what I'm wondering is if they change the selected tune, all right, again, it comes down to the life cycle of this thing. Here's the player. Right now, when you say play, we go create it. I don't think we need to do that. I think we should be doing this when they select something. A selected tune gets used down here. We find it. Right. I think we should configure it. All right. I think we should make one originally. Make an empty one. Then we know player is always set. Okay. So let's do this. SoundPlayer.make with nothing. Okay. So we're going to create a player that's holding nothing. That's going to create, well, it doesn't have an existing player, so it's going to delete, it's basically going to return. And then come and configure it with no notes. All right, but configure builds the new player and all that stuff. I guess there's no advantage to it per se. All right, let's see if there's any harm. I think what I want to do is configure it. I think. Well, what I'm hoping, okay. I mean, I'm getting rid of a bunch of optionals. That's something. What I would like to do is, if the tune changes, I would like to configure the play. I would like to call this when the tune changes. I don't know if it's worth it. I mean, it doesn't seem long. These are pretty, I mean, this one's, 100 notes long. That's longer than somebody's going to really want to sit for. So maybe I don't need to worry about it more. But what I have possible is I could do all the configuration when they change their selection. So at the point they change, I could build the new song right there. And then when they go to play it back, everything's already built and ready to roll. It's not a bad thought. But I think from the performance we're seeing, I don't think it's really necessary either. Okay, good. Yeah, this is making things a little better. Okay. So stop. Okay. Yeah. All right. So I guess I'm going to leave that. I don't know if this would be... Can we get that? Hit play. It says play, play. Return sound state. Okay. We've set that and published it. We're ready. And error if there's an error. I don't think anybody's really looking at the sound state other than to get the error message. So this, let's find usages of this. I don't think anybody cares. Right? Message is interesting. That's owned by a parent class. All right. I don't think we need this stuff. Okay. So this should break these three. Okay. We're not going to worry about this or this. We're checking the message, so that's good. Okay. There's one with an error. All right. And then... somebody should be complaining. Come on, I just deleted your field. Sound state. There we go. Okay. I'm gonna say let. If sound state is that, then message equals that. Okay, it's a little better. Sound state is ready. We don't care. Okay, same kind of thing. If there's no message, excuse me, before we've done the stop, the message goes away. If we find an error in doing it, we set the message. All right, these, I think I got everybody. Test should pass. We had some checking the message, so that's okay. Get rid of that warning. Okay, so remove unused sound state. Alrighty. Well, we've been going for a while, so I think we've hit Stop the player when the tune finishes, we don't do. Update the player state, we don't do that at all anymore. Improve the speed scale. Those are pretty easy. This one's a little uglier. Let's do this one immediately after we get back, and then we'll deal with that callback. And I think let's just put this as part of our notes, and we'll delete that. Okay. Just sort of a note for here. Okay. All right. So let's take a break. We'll come back and fix the speed scale, and we'll get that callback working enough to stop the player when the song finishes. Not delete it, but just stop it. All right. I'll see you in about 3 or 4 minutes, and we'll pick up from there. Hi, welcome back. So we said we would do the speed scale first. Let's see what that's about. All right, so this is the current version of it. It says playback speed, and you just you work this slider. It ranges -2 to 2 because we're doing some power of 2 thing, but that's not the way music works. Normally you talk about beats per minute. So I want to change this through. It's going to make it weird because we haven't done the right thing here. Okay. But what I want is, I think I want to say it ranges from 30 to, I'm thinking 360. So the default is 120. Let's see. And how do I get that default? I think it's on slider. I don't know why it defaulted to 0. But I think we can just give a default value or something. Oh, initialize speed. Ding dong. Okay. And let's rename this beats per minute. Is a very musical term for what's going on. Okay, so 123.60. Okay, that doesn't affect that. What does get affected? Okay, where's the player? All right. Nope. Where's the stage? The stage uses that when he's setting the speed here. Power of 2. No. He's got to be. Well, let's let default beats per minute equals 120. That's the real deal. And you calculate that speed based on, well, basically we're going to divide 120 by the speed. Okay, so default BPM/speed. Okay, and there may be a test that cares about that. Wait, where speed's coming in, right? Yeah. Int, yeah. And actually, this is not our job, but let's push it through. All right, so now I feel like some test ought to be complaining, but let's see if it does. Okay. Now what's going on here? SoundPlayer play does not care about the beats per minute. Oh no, it does down here. Okay. And then let's call speed is BPM as well. Yeah. Hey, welcome, Alvy. Apparently that's not going to do it. All right. Let's see what the test is. Test playback speed. Yeah, 60. Okay. As opposed to 4. There was somewhere a factor of 4 going on too. I don't know. Let's see. Soundstage. Okay, BPM. He basically passes on to the player. We calculated it as default divided by speed, which really should be BPM. It wants. Oh no! How does that go? Well, this is worse than I thought. Okay, so we used to go from -2 to +2, and then that was the power of 2. Now we're going from 30 to 360. $30 is 0.25 in our old scale. -2, I guess. All right, let me revert this thing. Soundstage. So what we're doing is we've got this playback speed thing, and right now it originally went from -2 to +2 because that's like the right power of 2s to to talk to this MIDI system we're working with. But really I want to use musical numbers, which are more beats per minute, which goes from 30 is really a reasonable, really low, and 360 is really fast. So we're using those here, but the formula to convert it is really not obvious. 360 is 3 as opposed to 4. Let me find the documentation for this thing and see if we can make sense of it. Yeah, the default, we want 1.0 to correspond to 120. Okay, so I think if you take 30 divided by 120, you get 1/4. Oh. And 360 by 120, you get 3. That feels okay. I think I did the division the wrong direction. All right, so not SoundPlayer, but SoundStage. Let's put them in the right order. Okay, so right now he takes the power of 2 to the speed. That's way fast with 30 to 360. Okay, so I think what we should be doing, let's change this to beats per minute. Oh, come on. Xcode, man. All right, BPM. Do it manually. BPM. Somebody's going to complain because this, yeah, label. Speed is BPM. Okay, beats per minute. All right, now SoundStage, honestly, it should just be passing BPM through. This mapping is we want to keep things in the music domain here. All right, and then he just plays, he returns it at that speed. Passed in, okay. This should still get an error because now we're not doing the math anymore. But I think we should correct the test and then make the player deal the right thing. Okay, playback speed. If we pass in, okay, yeah, something's wrong. Okay, anybody else? 2 should really be 120. Okay. No, 240. 2 times the default base of things. I don't think it's really going to matter deeply, but do not match those of written method. Insert speed. SoundPlayer play is in SoundPlayer. SoundPlayer play. Sorry, it's in stage. SoundPlayer play should be BPM. Whoops. Playback speed 4. It's really so much better when Visual Studio does this, or Xcode does its job. All right. So now, what's coming back here? I think his speed should be 2. I mean, if you want 4, well, let's do the maximum we're going to allow is really 3x. Okay, so I think the test should pass, but the speed is going to be wrong. We're going to have to do some work. Let's do a rebuild. Oh no, stage playback speed. That's from our helper. Nah, something's. Playback speed is beats per minute. Okay, so it's going to be the 360, not the 3. Or, yeah, it should be 360. Okay, we're just recording what's there. All right, test should pass. However, we've moved this computation into somewhere that's not part of the test. All right, so let's find that. Where's that 120? Okay, well, that's really... this is really... Well, that's okay, I guess. But SoundPlayer is going to have to deal with it. So he takes the speed. This should be beats per minute. Local rename, that's good. Okay. Now this thing, let's let speed equal beats per minute divided by default beats per minute. And I know I created that somewhere. No? Okay. That is owned by this. Okay, so default. So if we give it 30, it's going to be a quarter. If we give it 360, it's going to be 120. Sorry, if 360 over 120 is 3, that sounds better to me. All right, so tests don't have visibility here. All right, where are you? I thought I had this set to not do that. All right. Open a file. Take our short example, our sound. Okay, so that's 120. Let's do triple. That's a little too fast. Okay, let's do this. That's still pretty fast. What's going on? Let's see. Is my formula just not right? Okay. SoundPlayer. Oh, I said BPM there, not speed. Didn't complain about an unused variable. Interesting. All right, let's try that. So this is exactly where we can't test things with tests because this is all the low-level control stuff, unfortunately. I keep saying that, but it's true. All right, now let's play triple speed. And number 3. Okay. Let's play 1/4 speed. All right. Now, one more view thing I'd like to do is I'd like to put a little text box in here. Let's see if I can. All right, so if I add, you'd think there'd be a better view here, but all right, the text there. All right. This is going to be something BPM. Beats per minute. And let's update the preview. I really would like let's cast this to int. Right. And now bring forward. Okay, so do you update 30, 360? All right. Okay, so calculate BPM in SoundPlayer. Well, it's really convert BPM to audio toolbox speed in SoundPlayer. Add BPM to text to slider. And we may tune that speed. I mean, 360 is pretty darn high. Let's do it again. Maybe that's not bad. I mean, we can hear the tune and hear that it's similar, and we can listen to this one. Sounds like it's in a different key, but it's the same tune. And this one that supposedly is the same doesn't sound like it to me. What do I know? All right. I think this is lovely, though. That's what I want there. All right. Let's go back. I think we checked in. All right, let's update our notes. To do improve speed scale. We can fix the wording on that. So this is really make speed scale work in beats per minute. Good. Okay. And then the last one, this stop the tune thing. All right. I think we can do it. So it has nothing to do with the view or the sound stage. It's only a player issue. Oh, I don't know if I ran that test that one last time. Let's just double quick make sure. Okay. So what we're going to do is we want to ensure that a kind of garbage event, neutral event, I don't know, a marker event gets called. I don't think we could. Did we pass nil to this? Let's try that. I think we tried it and it didn't like it, but I wanted to try it again. Yeah. Okay, so that won't work. So we do have to have some garbage data there, or, marker data, whatever you want to call it. Unused data. All right. And I don't think there's a reason to make it anything interesting. 1 byte of 0. That should be all right. All right. So what do we have to do this? And is it going to screw things up? All right. If you hit stop, it's not going to get there. So I don't think that's an issue. I think what we're doing. Player start. Oh, interesting. Why are we calling start before we set the callback? I think that's kind of bad form. We really should set the callback before we start the player. I think what we did was we started it playing, and then before it got to the end, we shoved in one last event. Like, ugh, not cool. Legal, but not cool. All right, make sure this still is. Okay. That's all right. Okay, so what we have to do is we have to know when our last event is so we can get some time off it. If where time starts at 1, okay. We'll have to find out our last note. We'll have to stick this in. We'll have to create this callback. And it's going to have to come to, I think it's going to have to be living in our SoundPlayer. Okay. Woof. This is really, I don't know, it's very awkward for us. I mean, I could do some weird little marker thing that says, "Oh, you get a -1." That's no good. That's a stop. It's a user event, and I may need to. We're getting back an array of node infos. Right. I mean, this is the point we know. At the end of NoteInfo, we know the beat, and we know that that's where we should be sticking this new event. Okay, so I'm going to write this mini note message. I think notes, really, it should be more complicated than this. It should be an enum. Okay. This is really like MIDI note info. So this is enum note info case note is MIDI note info. Okay, and let's fix people to deal with this enum now. Okay, so append dot note of MIDI note info, like that. Okay, so we're appending to note infos the MIDI note info type. Then this, we have to do a switch and this is really case note of I have to say let here. MIDI note info. This becomes MIDI note info. Okay, so we're still in the case MIDI note info. All right, and then that seems to be it. So I'm generalizing my type to this enum, which is really kind of a union type. And tagged union maybe more accurately. Let's make sure this, well, test shouldn't, no, they care. MIDI note info, the test's gonna break. Okay. Map $0. What is actual? Is note info. Okay, so actual map. Let's say $0 add, no, that's not going to work. Okay, now I have to peel these things back off, which is a pain, and that's why I'm trying to avoid it. All right. They are NoteInfos. Okay. I think what we're gonna say is expected. I think we're gonna have to define these as being NoteInfos. Okay, so let's map. Let's map expected notes dot map to, well, I think it's going to be NoteInfo dot note of MIDI NoteInfo of note duration and time. Okay, the note is $0 because that's the pitch. Durations should be, well, I think this is easier to just do. Sorry, let's, instead of mapping it, let's just build an array. All right. We're expecting a note of MIDI note info of pitch.middle C. Duration is 1.0. Time is 1.0. Okay. This one is middle C plus 2. Duration is 2. This one's duration is 1. Time is 2. And this one is 4. And he is also plus 4. Okay, does he not know? Okay. This is array of note info. Okay, those are stop complaining. All right, now I can just assert the arrays. Equal, assert, equal. We want actual versus expected. And then we can get rid of these. That seems doable. We can synthesize it. And the values we're comparing, the floats are all just simple integers. They're not going to have a problem with the fuzz type stuff. Okay. Build that. I think that should be better. Really? I have to break myself of that habit, aren't I? Okay. Function. I don't think we're picking up on things. Okay, now we've got the same kind of thing here. The notes and the rests and all this stuff. Okay, so let's put expected in. Oh, and I don't need expected notes now. Middle C plus 2 plus 4. Okay, that's fine. We were expecting those three, 1, 2, 1, and then 1, 5, 7, because we're adding a rest in. And then this can be the same. Oh, come on. NoteInfo conform to equatable. Oh, I did it on mini NoteInfo, didn't I? Okay. It can be dot. All right. All right. So we've converted SoundPlayer to write NoteInfo rather than MIDI NoteInfo. Okay. All that was a bit of pre-refactoring. Okay, because our new approach, we really want to make sure there's, I'm going to call it a stop event. We want to make sure that this stop event gets into the track. That's this one. And he doesn't look any different than these if the note, well, he is different, I guess. He's a user event, but his stuff is similar. Okay, so we can do this. And we're going to do it from a test point of view. All right, so if you give these three notes and they 1, 2, 3, 4 quarter notes, all right, then I expect a stop as the last thing, okay? And he's got to have a time. All right, so his time, I think it's going to be 5. Okay. And this one is going to be 8. Because I believe this is saying start at time 7 and then end at whatever your duration is. So this should be 8. Okay, NoteInfo has no member stop. Well, let's fix that. Stop with a float 32. Okay. I don't know if somebody's going to be complaining. Okay, good. All right. So if we get this case, all right, then the next case is stop of let stop time. And let's just say break for the moment. Okay, I don't mind a little warning because I'm not going to leave it there. All right, now stop. Okay, stop. That's the code we're going to have to work on. Time. Oh, okay. He's not really a label, is he? Okay. Test should fail. 2 tests should fail. Because we're requiring everybody to stick a value in the stream at that point. All right. And what's the warnings I saw? Stop time never used. Yeah. Okay. This failed. It was 112517 112517 and a stop. Okay. Alrighty. So this SoundPlayer has to, where's the TUNE-info? Here we go. This is the configure, so at this point he should stick that event that we saw in the playground in. So let's make event data. No, that's not the right place, is it? That's the interpreter, but the TUNE-info. If caselet note equals symbol. Okay, let's do a switch on symbol instead. Case.note, let note. Oh, so annoying. Result.append. Stop, let stop time. And do a break. All right. I think I got an extra one here. Okay. We're going to do that in the two cases. Okay, before it did it regardless, now we have to do it regardless. All right, for each symbol, symbols. Oh man, I just messed that one up, didn't I? Okay. All right. Okay, so the thing we're not supposed to do, this is taking the symbols in, there's notes and rests, and building up result, right, appending to it. We need to append our stop value. Okay, so we need a stop, and the float 32 should be beat at this point. Okay, so here's our event data. All right, and then we, oh, well, I guess we don't even need that. We just need to append stop of beat. Okay, so if the last note was a quarter note, we added in its duration, and now we have the beat of the next note to appear, which is going to be our stop. All right, and I think, well, it's complete down here. Yeah, okay. We don't do anything with it because that's the part that we had to call the MIDI event there. But the tests that look at the note info, they should see the right note info now. That any song that comes in should have the right notes and a stop marker. Yeah. Okay. Whew. All right. Now this is where we need the event data. So that stage didn't convert it to MIDI, it converted it to our intermediate one. And we need to find where it's converting MIDI and add our event. Okay, so SoundPlayer, here's the event. And then the player is going to do this. This should be status. Track exists. I think this is stop time. Really? Double? Music timestamp is double. Well, okay, we can change this. It's just so inconsistent. All right. Event. I don't know where that's. I'm not sure what that complaint is. The editor probably fixed it. Okay, stop. Beat. Can't convert to double. Yeah, fine. But these durations need... Okay, bizarre. Okay, so we've added in the new user event with the right time, and I think track is already exclamation pointed, so we don't have to. Event data. Why track new user takes... We got to look at this. Track new user takes a double for stop time. Track new user takes in a music timestamp. Is float 64, which is double. Okay, and then the other one, MIDI note event, apparently takes, oh, maybe that is a double two. Okay. Let's define these like that then. Okay, so I don't think I need this. If this duration, no, time is a timestamp. Okay. And this one should be a timestamp. Beat should be a timestamp. MIDI NoteInfo cannot. Duration is float. Okay. Well, let's make it music timestamp. Well, let's make sure the durations are not let's see, MIDI note message. Duration. Oops. MIDI note message, is that mine? No. Duration is float 32. Oh, geez. Okay. Okay, you used two different floats for it for whatever mysterious reason you had. Let's do MIDI timestamp. Music timestamp. Okay, MIDI NoteInfo needs a float. Is it a float? Where's that? MIDI note event. MIDI note event. Timestamp. MIDI note message. The duration's a float 32. Okay. Let's use their types. Where's duration? Okay. All right, and I'll take the, yeah, because we added the code. All right. So what have we done? Well, all right. In NoteInfo, we append a stop event at the current beat, which is a float, a double. All right. And then when we interpret this and turn it into the real MIDI notes of our track, we create event data and add that user event to the thing. All right. So that should work. The MIDI note event is going to be a do nothing. I guess I can require that, but all right. Sorry, let's run that again. Okay, we'll open file. ABC, have a look at sound. Let's take the short one, run it pretty quick. Okay, but that should just play. All right. Now, we haven't incorporated in this stopping stuff. All right, so where's our callback? Let's take it a little bit at a time. Okay, so this stuff I do not intend to test other than manually, unfortunately. All right, so here's our callback. I don't even care about these two. They're not giving me any information at this point, so let's take those out. Okay. And we'll just print a callback event time. All right, now get this thing embedded in. All right, so music. Nope. Set user callback before the start. Okay, so let's find our start. Now, I'm kind of assuming where's sequence? So we probably want to do that up where sequence is defined. Okay. Here. Sequence has already got an exclamation. Okay, so we're saying you've set up your player. You should set up this callback whenever whenever the track finishes and gets that stop message, if it does. I think the two paths, right? It either runs to the end or it gets stopped in the middle. Now, we expect the callback to print out something, but we don't have a way to tie it in to the SoundPlayer object at this point. It's a free-floating thing. I think we can change that, but let's get this working first. So this should just work. We worked hard to discover it, put it that way. I thought I was surprised earlier we weren't getting that message, but all right. Doesn't affect the run. And we'll call sound, no tunes. Open this one and we'll take the quick tune. It should run it and print at the end. All right. Cool. So I think what we want to do, TUNE-23 is called once per thing. All right, let's pull this in. And then who's setting that? It's in here. All right, let's do that. Okay. That should be fine as well. All right. But now we've got it in local and we can update it to get to the current scope of things. All right. So sound. And it should do the same thing. It should print out when it gets to the end. We saw 40.5, so I'm guessing it's 40.5. Okay, now I want to call this okay. We know music player is not nil because we're in the middle of this. Okay, so self.stop. Okay, so oh no. C function pointer cannot be formed from closure that captures. Okay. Well, I guess that's going to give us somewhere to pick up tomorrow then. What we have to do is pass the self object through this user data that gets called to us. So if we go look at music sequence callback, the first argument is this unsafe raw pointer. That's going to be the data input data that we passed in here. And so we're going to try passing the address of itself and let it peel that apart. It's so unsafe. Optional unsafe mutable raw pointers. Yeah. Okay. But we're going to pass the address of ourself, cast that back to a sound player, and then call stop. But that'll be tomorrow's fun. So I'm happy we got this far. We're getting our call back, and it's sort of proving that we can kind of detect that ending moment. And recall, we have to stop this thing because if you don't stop it, it just keeps running forever. I don't know how long forever is, but it's longer than we want. And so I think we can make this go. It's a little awkward, but we'll get it there. All right. Well, thanks for joining today. I think we're very close to the end on this capability. I know we had an article that talked about doing this, so maybe that's this one. Yeah, I think so. We'll follow up with this article tomorrow. If not, I'll find the one that was describing it, but I think we know what we have to do and we'll do it. So anyway, next session is tomorrow, Tuesday at 1 to 3:30 p.m. Eastern Time or 6 to 8:30 p.m. UTC. Thanks for joining. Hope you have a good evening and take care. Bye-bye.